So the function that we did, the first example that we did, which was y equals x squared plus 1 cubed, is an example of probably the most common type of composite functions. Of probably the most common type of composite function. That is y equals u of x to the power n. So here we have a function u raised to some power. Now, the rule for differentiating this type of functions is called the general power rule. And it happens to be an example of the chain rule. Okay, so let me write down what the general power rule is, and we will do some examples on them. Okay, so if you're given y equals u of x to the power n, where u is a differentiable function, and function of x, and n is a real number, then the following is true. The derivative of y with respect to x is equal to n times u of x to the power n minus 1 times the derivative of u with respect to x. So this first part shouldn't surprise you, this part right here, because this is basically the power rule. Remember the power rule? The power rule said that if you're given something like y equals nx to the n, then the derivative of that is equal to, if you're given y equals x to the n, then the derivative of that is nx to the n minus 1. So here what's going on is you're taking that derivative, that part, you're doing it the way that you used to, because notice that what we're given is something very similar to this, but because our u is a function, we have to multiply by the derivative of it, which is where the chain rule comes into effect. So we could say equivalently, we have the derivative with respect to x of u to the x, of u to the n, is equal to n times u to the n minus 1 times u prime. And this is a u, not an n. Oh no, that's an n, my bad. That's an n, this is a u. This is an n as well. This is a u prime. Okay. So this is the general power rule. This is probably the most common type of problems that we will see in this class. And to be quite honest, it is probably the simplest one of them as well. It's pretty straightforward. So let's do an example. We did another one, an example of this when we first talked about the chain rule. But let's find the derivative of the following function. F of x is equal to 3x minus 2x squared cubed. Okay, so if we notice here, our u of x is equal to the inside piece. It's equal to 3x minus 2x squared. And we can see this because from the rule, that's what we have. Y equals ux to the power n. So here, the green piece is the ux, and the power is 3. So what is the f of x? Well, f of x is really equal to u cubed. And the reason why f of x is equal to u cubed is because we are saying that u is equal to 3x minus 2x squared. So since this is equal to 3x minus 2x squared cubed, and we just call this inner piece u, then this is the same thing as u cubed. Okay, so what is the derivative of u? What is u prime of x? The derivative of u is equal to 3, because the derivative of 3x is just 3, minus 2 times 2 is 4, and then 2 minus 1 is 1, so minus 4x. The derivative of f is going to be equal to 3u squared. Now we can apply the general power rule. I mean, we just did. I took the 3n squared by the power rule, and then I just have to multiply by the derivative. And we have the derivative right here. So let me just write once more the general power rule. It says do n times u of x to the n minus 1 times u prime. And we have all of these now. So this is 3u squared times 3 minus 4x. Notice that I'm putting the u prime in parentheses. This is u prime. The reason why I'm putting it in parentheses is because this is a binomial, and there's a negative sign in the middle. And when we multiply a binomial by a monomial, we have to distribute to the first term and then to the second term. So if you're asked to simplify, you need to keep that in mind. It's not going to be just 3u squared times 3. A lot of students make that mistake. They only multiply times the first term and not the second term. The problem was given to us in terms of x's, so we should rewrite this u for what it actually is. U is equal to 3x minus 2x squared. So this is equal to 3 times 3x minus 2x squared. And this is being squared times 3 minus 4x. We can actually leave the problem like this. I'm not going to simplify, because simplifying this is just a matter now of some basic algebra. You square this, you multiply through. So I trust that you know how to apply some basic algebra at this point in the game. So that is what the derivative of u is. Now, let's do another example, just to drive the point home. Let's say we want to find all the points for which the following function is equal to 0. So let's find all points for which the derivative f prime of x is equal to 0. Actually, and let's also find all points, because it's not that difficult, for which f prime of x does not exist, where the derivative does not exist. It's also not that difficult problem. Now the f of x that we're working with is the following. F of x is equal to the cubic root of x squared minus 1 squared. Alright? So when you're given something like this, it is always good to first rewrite. So we're going to rewrite it. f of x equals the cube root of x squared minus 1 squared is actually the same thing as x squared minus 1 to the power 2 over 3. This is from a fact from college algebra. So recall, if you have x to the a, you're taking the b root of that, and that is the same thing as x to the power a over b. And clearly b is not equal to 0. Okay, so that's what I'm using here, that particular fact. Okay, so now that we have rewritten this, we can actually see that this is going to be a case of the power rule. So let me just once more rewrite the power rule. That's d dx of u to the n is equal to n times u to the x to the power n minus 1 times u prime, times the derivative of the inside. Alright, so let's find out what u is. U here is going to be the inside function, which is the parabola x squared minus 1. This is the parabola x squared shifted down 1 unit. And our f of x, or our f of u, I keep writing f of x, f of u is equal to u to the 2/3 power. Which means that the derivative of u is equal to 2x minus 1. And now, by using the general power rule, we know that the derivative of f of u is going to be equal to 2 over 3 times u to the power 2 over 3 minus 1, which is the same as 3 over 3, so that's going to be negative 1/3. If you didn't see what happened there, 2 over 3 minus 1 is the same thing as 2 over 3 minus 3 over 3, which equals negative 1/3. Okay, that's just subtracting fractions. Now we can actually find the derivative. So d dx of f of x is equal to 2 over 3 to the u to the 1/3 times u prime. That's basically what this says. Okay. Now we just have to put it together. So u is x squared minus 1, u prime is 2x minus 1. So this is 2 over 3 times u, which is x squared minus 1 to the 1/3, times u prime, which is 2x minus 1. Again, u prime is this, u is this, and we're just substituting. Okay? U of x to the n minus 1, it's right here. The n on the front is this 3 from the exponent, times u prime, which is right out here, right out here. Our u prime is 2x minus 1. And then now we just have to put it together. The calculus step ended right here. At this step, the calculus has ended. Everything else that follows is, college algebra and arithmetic. So we could actually multiply that 2 out, which is probably the one thing that I will do. So that's 4x minus 2 in the numerator. And then the denominator is going to be 3 times the cube root of x squared minus 1. So that's what our solution would be in radical form. But now we actually have to find out when this is actually equal to 0 and when the derivative doesn't exist. Because that's what I asked for. I asked when does f prime of x equal 0 and when does f prime of x does not exist. So this is the questions that we're asking ourselves now. And f prime of x is this is the derivative of f. Well, the only way, so I mentioned this in passing a lot, But recall, the only way for a fraction of the form a over b, and b is not equal to 0, to be equal to 0 is if the numerator is 0. Okay? That is, a is going to be 0. So the only way that that numerator is equal to 0 is if x equals 0. Let me just make sure that I didn't make any mistakes here. I think I did. This doesn't look right. Yeah, I made a mistake. The derivative of x squared minus 1 is not 2x minus 1, it's just 2x. But since this is an online class and there are no students to correct me, I have to correct myself. So this is just going to be minus 4x. There we go. That looks better. So now we see clearly that 4x is equal to 0 precisely when x equals 0. You could divide both sides by 4 and you get x equals 0. So the only way that f of x is equal to 0, so f prime of x is equal to 0 when x equals 0, because of what I wrote here. The numerator has to be 0 for the fraction to be 0. Now, for what values of x does the derivative does not exist? Well, those values of x for which the derivative does not exist will be the values that will make this fraction undefined. Remember, if we have undefined, then the derivative doesn't exist, because that means that the limit doesn't exist, because we will have asymptotes. Remember that the limit we define, the derivative we define in terms of asymptotes. So let me just recall, f prime of x is equal to the limit as h goes to 0 of f of x plus h minus f of x divided by h. That's what we call the derivative. And this is a limit computation. So the derivative, for the derivative to exist, this limit has to exist. But if we have a value that makes the function undefined, then the limit doesn't exist at that point, because that will mean that it's not continuous at that point. In any case, what values of x will make this undefined? Well, anything that makes the denominator 0 will make this undefined. And anything that makes the inside of the square root, well, this is a cubic root, so it doesn't matter, but anything that makes the inside of the square of the cubic root 0 will make the whole function undefined. So we simply have to solve for when x squared minus 1 is equal to 0. Yeah, x squared minus 1. So if we add 1 on both sides, we have x squared equals 1. And then if we take the square root on both sides, we have that x is equal to plus or minus 1. Okay, so now we have that f prime of x does not exist when x equals 1 or x equals negative 1. And we can see that if you plug in 1, you're going to have 1 squared, which is 1. 1 minus 1 is 0. The cubic root of 0 is 0, and then 3 times 0 is 0, so the denominator is going to be 0. Similarly, if you plug in negative 1 squared is plus 1, and 1 minus 1 again is 0, and the cubic root of 0 is 0, and 3 times 0 is 0. So again, the denominator will be undefined. So this is a neat problem. We did a lot in this problem. But the most important pieces were rewriting this so that it's easier to solve. All right. What about when we have a quotient? So the chain rule is pretty useful when we have quotients as well, because it helps us it helps us avoid the quotient rule. I particularly do not like using the quotient rule that much. I prefer to simply rewrite my fractions and use the chain rule. Sometimes it is easier to just do it that way. So let me remind you once more, in this particular problem, when we're taking the derivative of something like f of x over g of x, we could use the quotient rule that says, g of x times f prime of x minus f of x times g prime of x divided by g of x squared. So we could use the quotient rule, but we could also use the chain rule, and this is what I prefer to do. I prefer to simply rewrite this. So let's rewrite g of t. Remember that when you have something in the denominator like this, like a to the 2, this is the same thing as a to the minus 2. You can always bring it back to the top. So this is the same thing as minus 7 times 2t minus 3 to the negative 2. And now we clearly have a case where we could use the general power rule, because we have a u of t, in this case on the inside, raised to some exponent. And because we know that the constant multiple rule applies, this 7 is really meaningless, meaning we just multiply whatever we get with the derivative times this minus 7, and we'll be golden. So for this particular problem, u is equal to 2t minus 3, and our g of u, let me call it f of x since I've been calling it f of x throughout. So f of u is equal to minus 7 u to the minus 2. That's what f of u is. The derivative of u is simply 2, because the derivative of 2t is 2, and the derivative of a constant is 0. So the derivative of 2t minus 3 is 2 by the power rule. The derivative of f of u is equal to minus 7 times minus 2, which is plus 14 u, and then if you minus 1 from the top, you're adding 2 and 1, so that's minus 3 in the numerator. So we have that the derivative with respect to t of g of t is equal to 14 u to the minus 3 times u prime, which is 2. This is the same thing as 14 times 2 in the numerator divided by u cubed in the denominator. You move the things with the negative exponent to the denominator. Well, 2 times 14 is 28, and then u was 2t minus 3. So this is 2t minus 3 cubed. And we could leave it like this. We could leave our solution like this. Okay? Now, let's do another problem like this, but a little bit more complicated, a little bit more challenging. Let's say we are given f of x equals x over cube root of x squared plus 4. If you're given something like this is a bit more challenging, because now the numerator is a function itself, it's not a constant. If you were to be given something like this and somebody told you find f prime of x, find the derivative, then what I recommend that you do is that you first analyze it. Yes, here you will use the quotient rule. I mean, you could try to avoid it, but if you try to avoid it, then you'll eventually have to take the product rule, so it's still going to be a mess. What I will first do is try to rewrite as much as possible. So I'm given this in this form, cube root of x squared plus 4. I'm going to try to at least rewrite the denominator into something that looks much nicer, like x squared plus 4 to the power 1/3. And now, here, what I will do is I will actually use the quotient rule to solve this. And once again, I'm going to write the quotient rule here. So if you're taking the derivative with respect to x of a quotient of this form, then this is simply the following. minus f of x times g prime of x over g of x squared. So again, the way that I remember this is low the high minus high the low bottom squared. That's what I say. In my head, I'm saying low the high minus high the low bottom squared. That will help you memorize this. Repetition is key. In any case, if I'm taking the derivative of f, and this is f, what I will do is I'm going to first find out what g of x is, and instead of f of x, because I'm calling this function f of x, I'm going to call this other one h of x. But just so that you could see what's going on, h of x is going to be my numerator, g of x is still going to be my denominator. So h of x here is x, g of x is x squared plus 4 to the power 1/3. So we got to be a little bit more careful. Let me give myself more space. When applying the quotient rule now, we have to be a little bit more careful. So we know we're going to have to find h prime of x. Well, the derivative of x is just 1, which is good. That's going to make our life easier. But the derivative of g prime of x, we have to use the chain rule to evaluate this because this is a case of the general power rule. We have function on the inside, and then we have it raised to some power. So I'm going to do it without actually breaking it up like I was doing. So again, by the general power rule, we bring the 1/3 to the front. So I have 1/3 times the inside function, that's not changing, x squared plus 4, times the derivative of the inside function. The derivative of x squared plus 4 is simply 2x, because the derivative of x squared is 2x and the derivative of 4 is 0. So what we really have here is that g prime of x is equal to 2 over 3x times x squared plus 4. I simply just move the 2x to the front and multiply it by 1/3. And I'm not going to distribute this on the inside yet, because it's not going to be as useful. But now we can actually apply the quotient rule, because now we have all the information we need. So again, the power rule, the quotient rule says low the high minus high the low bottom squared. So low was g of x, so that's simply x squared plus 4 to the power 1/3 times the derivative of the top, which is just 1, minus high, which is just x, times the derivative of the bottom, the low, which is 2 over 3x times x squared plus 4, divided by the bottom squared. And the bottom was x squared plus 4 to the 1/3, and that's now being squared by the quotient rule. So as you can see, this is already getting very messy. We have a lot of things going on, and that's why I added extra parentheses to make sure that I keep track of what's going on. So this derivative, which I'll just call d dx, fine, I'll write it, f of x over g of x, is equal to what? Well, 1 times x squared plus 4 to the 1/3 is simply just x squared plus 4 to the power 1/3. But now on this right side we have x times 2 over 3x, so that's 2 over 3x squared times x squared plus 4, all divided by x squared plus 4, and then you just multiply the 2 times the 1/3, so that's to the 2/3 power. Okay? Well, now what? Now, what I'll try to see if there is something that I could move around. So let's see what happens. I have an x squared plus 4 in the denominator to the power 2 over 3. I have an x squared plus 4 in the numerator to the 1 over 3, and an x squared plus 4 as well multiplied by 2 over 3x squared. So let's see. Let's see. Yeah, I'll leave it like that. You get the point. I don't feel like factoring this. It's gonna take me a while. I will distribute this though, so it's gonna be minus 2 over 3 x to the fourth minus 8 over 3 x squared divided by x squared plus 4 to the 2 over 3. You could, simplify this a little bit more, and eventually you'll get some cancellation and it'll look nicer for sure. But I'm not gonna take the time to do it. It's just not important, or at least not as important. Let's do one more example, and this probably will be the last example that I do for the general power rule for this section. This video is getting kind of long, but all of these examples in this video are things that you definitely need to know. So let's say somebody comes up to you in the street and they give you something like this, and they tell you to find what y prime of this is. Well, here you have a case where your u is kind of complicated. Your u is this fraction up here. Your u, not up here, meaning this whole fraction up here, which is 3x minus 1 divided by x squared plus 3. So you already know that you're going to have to use the quotient rule on this. And then you have to use the power rule as well. So f of u is going to be equal to to u squared, because you're squaring it eventually, because of this square. Now the difficulty here is going to be, again, using the quotient rule to find the derivative of this. So the derivative of u is going to be the bottom, x squared plus 3, times the derivative of the top, which is simply 3, minus the top, which is 3x minus 1, times the derivative of the bottom, which is 2x, divided by the bottom square, which is x squared plus 3 squared. So once you get the hang of using the quotient rule, you'll be able to do problems like this in your head. Once you get the hang of saying, okay, the derivative of 3x minus 1, call it v, so v prime is just 3. And then you pick another letter, let's say z, we haven't used z. That's going to be the bottom, so x squared plus 3. So z prime is equal to 2x. And eventually you get the hang of it. But for the sake of time, I'm just going to do it quickly. Although I'm recording, so, it's not like I'm spending time on class. But anyway, so let's simplify a little bit. So we have x squared plus 3 times 3. So I'll just FOIL that out. So it's going to be 3. Well, let me give myself some space here. So u prime equals 3x squared plus 9 minus, and this is going to be 6x squared minus 2x on the top, divided by x squared plus 3 squared. So if we simplify a little bit more, u prime is now going to be equal to, 3x squared minus 6x squared, that's minus 3x squared. Minus and minus is plus, so plus 2x, and then plus 9, that's the numerator. And the denominator is going to be x squared plus 3 squared. I'm not going to simplify that more. But this is just the u. That's just the part of u. We still have f of u, which is u squared. So when we put this together using the general power rule, which if you remember was this n times u to the n minus 1 times u prime. We know what n times u to the n minus 1 is. That's just u squared. So this means that f prime of u is equal to 2u. So that's what we have here. Oops, sorry about that. So this piece right here is simply 2u times u prime. This is what we get from up here. Well, now what is u and what is u prime? Well, u is the fraction 3x minus 1 divided by x squared plus 3. So this is 2 times the fraction. What's the fraction again? 3x minus 1 divided by x squared plus 3. Times u prime, and u prime is what we found down here, which is minus 3x squared plus 2x plus 9 divided by x squared plus 3 squared. And now, if you want to, you could multiply this out. I'm not going to do that. I'm just going to write that as 2 times 3x minus 1 times minus 3x squared plus 2x plus 9. This is a perfectly fine answer for a problem. If I gave you a problem, this is enough simplifying. Notice that I have 1x squared plus 3 in the denominator times 2 of them. So this is just x squared plus 3 cubed. That's because we have this aside. So aside. In the denominator, we have x squared plus 3 times x squared plus 3 squared. So if we have the same basis, we add up their exponents. So that's equal to x squared plus 3 cubed. Okay? And that is the end of this video on the general power rule. The next video, I'm going to talk a little bit more about the general power rule and the chain rule with trigonometric functions and exponential and logarithmic functions. Thank you for your attention.